In this video we're going to take a look at showing a couple of results algebraically. So we've got a brief idea about what this sigma notation represents, and essentially we need to think about what we know about how to split this up, combine with these formulas to end up with like a general result. So we know that the sum of the natural numbers is equal to this. We know that the sum of the constants is equal to this. And we're trying to find like a general formula that would always work if we were adding up this series here, or this sequence. Now you can think about what the individual terms would look like r plus 3 would be, if we start with 1, that would be 4 plus 5 plus 6, etc. But we don't really care about what the individual terms look like. We're trying to find like a general rule that will always add up the first n terms in this sequence. Okay, now the way that we do it is we split it up. So we've got the sum of r plus the sum of 3. Now the sum of the natural numbers is equal to 1/2 n plus 1, and the sum, don't forget, from r equals 1 to n of 3 is not 3. Like that 3 is being counted n times. Like each of these terms would have an extra 3 in. So we say that's equivalent to 3n. So once we split it up and we've used our formulas, the next step, and this is a very important step actually, because a lot of students go a little bit wrong here. You don't want to expand. We look for common factors, so we need to get a common denominator first. And we want to look for common factors. If you just like start expanding everything out, you will get into a mess, especially on the more complicated questions. Okay, so we've got 1/2 and we've got 3, so obviously we can think about common denominator. 3 would be the same as 6/2. Now once we've got a common denominator, we can take this factor of 1/2 out of both terms. Like both of these terms, we'll take the factor of 1/2 out. They also share a common factor of n, so we'll take a factor of n out. I like to open up like a big square bracket and then see what we've got left. Okay, so key step, split it up, use your formulas, get a common denominator, take that out, and take out any common factors. Now what we've got left would be n plus 1. And if we've taken the 1/2 out of this, we've taken the n out of this, we'd be left with 6. So clearly for this first one, there's not much extra to do now, we just got n plus 7, which is the result that we were trying to show. Okay. Next example, we're trying to find the sum of the first n terms of 3r squared plus r, and we're aiming to end up with this as our answer. Okay. First thing we want to do is write it as 3 lots of the sum of r squared plus the sum of r. Now we can use the formulas. Okay, so 3 lots of r squared, which is 1/6 then, n plus 1, 2n plus 1, plus the sum of the natural numbers, which is 1/2, n plus 1. Now remember the key step, we don't want to start expanding stuff out. Okay, I know it's tempting when you see brackets, you want to expand them, but don't. Okay, well let's look for common factors. Now 3 times 1/6 is 1/2, so already we've got a common denominator, like they're both have a factor of 1/2 that we can take out. They also both have an n that we can take out, and they both have an n plus 1. Let's open up a bracket and see what we've got left. So we've taken the half out, n plus 1, so we're left with 2n plus 1. And just be careful with this. Sometimes people make a little mistake here and just like don't write anything. If you've taken the half out, the n out, and the n plus 1, you're left with 1, aren't you? Because remember, what we're saying here is if we expand this back out, it goes back to what we started off with. We're just writing this in a different way, so we do need that plus 1. Okay, so let's tidy up what we've got left. Half n, n plus 1. 2n plus 1 would be 2n plus 2. But we could go a little bit further than that. Look, now that we've simplified this, there's a common factor that we can take out. So that would be 2 lots of a half n, n plus 1, n plus 1. So we can take this factor of 2 out, and then the 2 and the half cancel. And then we've got n plus 1 times n plus 1, which is obviously n plus 1 squared. Okay, next example, example 5. We've got the sum of r times r squared minus 1. We need to split this up before we can do anything. So we can think about it as the sum of r cubed minus r, which is the sum of r cubed minus the sum of r. Okay, so the cube formula would be a quarter n squared n plus 1 squared minus a half n plus 1. We're looking for common factors. We're working with the quarter and the half. Okay, so you need a common denominator first. Think about the half as 2 quarters. And once we've got a common denominator, we can take a quarter out of both of these. So we've taken the quarter out of both. We can take an n out of both. And we can take an n plus 1 out of both. Taking the quarter out, taking an n out of n squared, so we're left with n. Taking an n plus 1 out of an n plus 1 squared. So we're left with an n plus 1. We've taken the n out, we've taken the n plus 1 out, and this is 2 quarters, so if we've taken the quarter out, we'd be left with the minus 2. Okay? Don't forget, think about that as minus 2 quarters. If you take the quarter out, the n and the n plus 1, we're left with this minus 2. Looking at what we're aiming to end up with, we've got the quarter, we've got the n, but then there's a little bit more, so let's just tidy this up and see what happens. So now we're left with the quadratic, n squared plus n minus 2. All we need to do is factorise, and hopefully we'll get to our answer. Is that what we wanted? Oh, not quite. Okay, notice we've got n squared minus 1, it's like a difference of 2 squares. Now if you look at our 2 brackets, we've got n plus 1 and n minus 1. And that's a difference of 2 squares, isn't it? If you expand that out, you'd get n squared minus 1. The other stuff would cancel. So I think it'd be reasonable for us to jump to the answer from there. So we've got quarter n squared minus 1, n plus 2. Okay? So key things to remember: split it up, common denominator, take out your factors, and it should hopefully be not too bad, this topic. Alright, thanks guys.